Welcome back. Next up, we're going to see another built-in function similar to map, but this one is called filter. So just like with map, where we can pass in a lambda and then an iterable collection, filter allows the same thing, but it works in a different way. So filter does what it sounds like. It allows us to take a list or a collection, a tuple, and filter out particular items that we want based off of an expression or a condition. So here's an example where we have a list of numbers from 1 to 4. And the result of running this filter is that we're pulling out the evens and putting them into a new list. And the way we do it is we use filter and then our lambda, which is going to return true or false. So anytime we use filter, whether we're using a lambda or a named function we've defined, it needs to return true or false. It needs to be a Boolean expression in that function. And that true or false is going to be how filter decides what to put in the new list. So as you can see here, this expression for every x, if x, well, it's not even if, it's just x mod 2 equals 0, that itself will be true or false. If that's true, filter takes whatever value, like 2, and adds it to the list. But if we're on 3, for example, this is false. It's not evenly divisible by 2. So it's not added, it's rejected and ignored. So let's do a quick example. I have a list of names here called names. And let's say that I want to make a new list with only the names that start with the letter A. So Austin, Anthony, and Angel, or Angel. And to do that, we could use filter. So we would make a new variable. We'll just call it A names equals. And we can start with just filter. And then the lambda we want, I always do the D first, which is wrong. It's lambda, not landba. And it will just take a name. We can call it name. It's okay, in my opinion, in lambdas to do short, single letter parameters, because the idea is that it's a single line. It's not ever going to be used again. So instead of doing name, I'm fine with n. And then we'll check if the first character, n0, equals A, just like that. So this returns true or false. And then we'll do that on every name in names. So just to reiterate, I have one too many colons over here. We have filter. This will return true or false, this lambda, for every n or name in names. Check the first character, is it equal to A? If that's true, add it to the new list. If it's not, ignore it. And if we look at A names, just like with map, we get this filter object instead of a map object. But if we turn it into a list, you can see we get Austin, Anthony, Angel. So hopefully you can see how this is helpful. Yes, we could still use list comprehensions, so I'm going to talk about that. But ignoring that fact, there are lots of times you might want to extract certain things from a list based off a condition. And what do you know? I have a little demonstration ready. So here is a list of users. Let's imagine I'm running a very simple version of Twitter. And I have people who are active and people who are inactive. And the way I can tell is, so there's a username for each person, Samuel, and then tweets is a key, and the value is a list. So Samuel has 2 tweets. I love cake, I love pie. He's really into pastries. But then we have someone like Jeff who has no tweets. So let's say I work at this company and my job, my task is to reach out to all of the users who have never tweeted. Do some sort of annoying thing like, hey, we noticed you signed up, but you never sent your first tweet. Like, here's an easy way to send your first tweet. You've probably seen something like that. Maybe not a tweet, but from some other company. So let's do that. Let's pull out all of the inactive users. So I could make a variable called the inactive users. And then I'll set it to filter. And what is the filter we want to do? Or what's the true or false condition? Well, for every item in this list, so let's start there. We're going to pass in users. Now, for every user, we're going to check if the tweets property in that dictionary, because each user is this whole dictionary, we're going to check if their tweets property has a length that's equal to 0. So let's test it out. And I'm going to show you one way of doing it first. So we need our lambda, and I'll just call each user U. And then we'll check, is U tweets? That's going to just give us this list. And we could check the length of U tweets, see if it's equal to 0. This is kind of a lot to take in if you're still shaky with this, but let's just walk through it. So for each user, U is the temporary variable representing this first one here, all right? And we're checking U tweets, so tweets gives us this list, and then doing the length of that, which would be 2. 2 is not equal to 0, so that would be false, so it is not added to the new list. But Jeff, his tweets, the list, the length of it is 0, so we get 0 equals 0, which is then going to add him to our end result filter list. Okay, so let's see, am I missing any parens? This looks good, but I'm going to turn it into a list, so we get this extra long thing, and then let's just print inactive users. And we get Jeff, who has 0 tweets, Bob123, 0 tweets, and Guitar Gal, who has 0 tweets. Okay, so there's a couple of modifications we could make. We could take advantage of the fact that an empty list is inherently falsy. Remember that values like an empty list, an empty string, and 0 are inherently falsy. So I don't even have to check the length of anything. I don't have to check if it's equal to 0. If I do this right now, U tweets is going to return true for every list or for every user except the ones that I want. So I'll actually get the opposite. Let me just demonstrate that. I get only the users who are active. So I could negate that with just not U tweets. So U tweets is going to return either a list or an empty list. And if it's an empty list, that's false. So then we'd be saying not false, which gives us true. Let's verify. There we go. We're only getting our empty tweets, people who have never tweeted. Next, I'm going to show how we can combine filter and map. So here's a list of names, Lassie, Colt, and Rusty. And suppose we wanted to make a new list with the string, your instructor is plus, Lassie and Colt and Rusty. So your instructor is Lassie, your instructor is Colt, but only if the value is less than 5 characters. This is what that would look like. It's kind of intense to look at it, but what we're doing is we're running map, where map is going to take each name and return the F string. Your instructor is name, but what collection is it running it on? Well, that itself is a filter on names. So this is going to run first, and it's going to make a list where we only have the names who are shorter than 5 characters. So that's only a list containing Colt. And then we're going to run this map where we make a new list where we map your instructor is, and that's how we get your instructor is Colt. I know it's kind of intense. So back over here with a more practical example, rather than just collecting our inactive users, let's say we only want to collect the usernames in our inactive users. We don't want the entire thing like this. We can actually use map to do that. So I'm going to comment these out, but I'm going to keep our filter like this. But then I'm going to write a map. So we're going to have a map where all we want to do, so we'll have a lambda, and for each user, we're just going to want the user bracket username. So this is a way to make a list where we're taking an entire user and only returning the username, okay? And just to be extra fancy, we could do .upper for no reason. And what collection are we going to run that on? Well, if we just ran it on users, it would do it for every single one in there. But if we only want the inactive users, we can filter first. So on a single line, it looks kind of insane. So I'm going to indent it like this. And we're almost there, except remember, map doesn't return a list. Whoops. So we need to then turn this entire thing into a list. It's crazy. I hope I haven't lost you, but all that we're doing here is first filtering out the active users and only getting the inactive ones, which we've already done. But we're passing that in to map. So map is building on top of this. It's taking that list of inactive users and for each one, adding it to a list, but only adding the username uppercased. Okay, and let's just save that to a variable called usernames, and then let's print usernames. And the moment of truth, there we go. These are our 3 inactive usernames, all capitalized. Oh, sigh of relief. We're done with that. So now the question that we're finally going to answer is, what about list comprehension? Why complicate things if we could just do a list comprehension? For example, this previous example of returning a list with the string your instructor is and then the name, but only for the names that are less than 5 characters, we could do that with a single list comprehension like this, right? Where we do the f string for name in names if length is less than 5. And that is way better in my opinion. And pretty much everyone agrees. This sort of syntax, list comprehension, is the bread and butter of Python. It's what almost everybody would prefer to use. But it's important that you understand that these exist, things like map and filter, that lambdas are around. Basically, in this case, in just an educational context, it's something that you need to know about when you move on to bigger and better things. You might see one on a project you're working on. The library or the package you download might require you to use one. Well, it wouldn't require you to, but it might have it in the documentation or something. But if you can use list comprehension to do the same thing like we can here, then we should. But earlier when we had this button, this is not something we could do with list comprehension. We need a lambda. So all of this stuff I've been showing you, map and filter, it's not something you're probably going to use very much. But it's good to know it exists. So don't hate me for teaching it. But let me just show you how we could change this over. Like if we just wanted to do our inactive users in a single list comprehension, all we have to do is for user in users, we'll just do user for user and users if, and then we just do user tweets, or we could say if not user tweets, just like that. We don't have to turn it into a list, right? It's already going to be a list. It's, in my opinion, so much nicer than this. This is what you would end up writing something very similar if you were using JavaScript, but Python has these lovely, beautiful expressions, list comprehensions, and I can just save this to, I'll call it inactive users 2, and then just print inactive users 2. Comment everything else out. And if I run it now, there's our inactive users. And to improve upon this earlier, or the second example where we used the filter and a list, I could do the same thing where I just do username dot upper. And yeah, it's kind of a long line, but I think this is so much better than all of this here. So let's try printing that, and we get the same result. Okay, I annotated this a bit. So here's the version to extract the inactive users using filter and a lambda. Here it is using list comprehension. We don't have to convert it to a list. Get rid of that print as well. Here, the only thing, I guess I should update this. Inactive users, let's go with usernames instead. If you're just looking at this code, usernames 2. So here is the monster combining map and filter to extract the usernames and uppercase them only of the inactive users. And here's the exact same thing with list comprehension. So the moral of all of this is, 1, I just needed to show something that used a lambda that we could wrap our heads around. 2, you might see something like this. You might see it around, or if you're coming from a language like JavaScript, this might feel more natural, but this is the Python way, and this is what you'll see by far more often. So that wraps it up for now. Now we're going to take a look at a bunch of other built-in functions that we don't have to worry about lambdas for. It will be a breath of fresh air after this nightmare that this syntax is.